Welcome to the Coventry and Warwickshire Green Business Programme podcast. Subscribe now for more episodes.
Hello, welcome to the Green Business Programme, which is part funded by the European Regional Development Fund and delivered by Coventry City Council, Coventry University and Coventry University Enterprises. There are several ways for businesses to embrace the green revolution, ranging from changes to lighting systems and investing in solar panels and other technologies, all the way through to using electric cars and vans. One technology we're going to focus on in this episode is heat pumps. I'm John Bates, and in a few moments I'll be joined by Bean Beanland. Bean is a founding member and director for growth and external affairs at the Heat Pump Federation. And later in the podcast we will look at two case studies so we can learn from the experiences of others. But first to our guest, Bean. Bean, I understand you're an active participant in the industry, supporting the development of heat pump technology, installer training and standards, as well as lobbying for government policy. Thanks for sparing the time to come on the podcast. Tell us a little bit more about yourself and what you do.
Well, firstly, thank you very much indeed for having me. Any opportunity to discuss heat pumps is gladly taken, so I really appreciate it. I've been in the industry now for far too long, really, about 14 years, I think, something like that, 14, 15 years getting on for. And I started life as an installer, actually. I spent my first 8 years in this world as a heat pump installer, well, multi-technology installer, really, but heat pumps was by far the biggest proportion of our work, and it was predominantly ground source, just the nature of the markets that we were operating in. And most of those were what most people would call hard to treat buildings. So we spent most of our time working in listed and period buildings, which sort of gives the lie to the concept that you can't put heat pumps into period and listed buildings, which I'm afraid is just tosh and nonsense. So I got heavily involved, started getting more heavily involved in standards and policy through my work as an installer, and eventually that started to dominate the things. So I ran the Ground Source Heat Pump Association for 4 years effectively, and as it was clear that the market for electrification was developing very strongly and very heavily, lots of new entrants coming in, we needed to give them a new place to go where they could be not dedicated to ground source, they didn't have to be heat pump manufacturers. And so the concept of the federation was born, and away we went. Our launch party, of course, was lost to COVID, March the 19th, 2020, but we went for a soft launch anyway. We're just nudging towards our first 100 members now.
Okay, so with your membership approaching 100, then that just shows that there's strong interest in this technology. But just explain to us, what is a heat pump and how does it work?
A heat pump does exactly what it says on the tin. It pumps heat in the opposite direction to that it would naturally move. So heat tends to move from a warm place to a cold place. And what we're using a heat pump to pump it the other way. It really is that simple. It uses a gas compression cycle. So it's exactly the same technology that sits in everyone's fridge, their freezer, in their car air conditioning. Many people now have heat pump tumble dryers. So the key here is that most people have got at least one, a fridge. The point of that is that this is not scary new technology. This is technology that we've relied upon to keep our milk fresh and our peas frozen for decades. We're just using it in a slightly different way.
Okay, and the plan then is to replace some of the traditional methods of heating or cooling. Then this is to try and move away from oil and electric. Is that right?
Ultimately to move away from fossil fuels completely. Yeah. So if you believe in climate change and you believe in global warming, clearly we need to get away from burning fossil fuels. We need to get away from burning anything, actually. The concept of burning things in a flame temperature measured in hundreds of degrees in order to get to just 21 degrees in Mrs. Miggin's sitting room is just, extraordinary, given that source temperatures for heat pumps, atmospheric and or ground or water, are so close to 21 degrees most of the time in the UK. For me, it's just an obvious use of a very, very simple, basic element of physics. So it's about getting rid of fossil fuels ultimately by 2050. Of course, we have net zero 2050 set in legislation. The initial targets will be oil We've largely got rid of coal in the UK, which is the most carbon intensive primary fuel that we were using. Oil is clearly the next target. So oil and LPG, what we would say is off grid, off gas grid, is the next target. And government are already now consulting on the potential and effective ban on the replacement of fossil fuel boilers off the gas grid, so oil and LPG boilers. We're waiting to hear whether there'll be exclusions for biofuels, biogases, bio-oils, but fundamentally, we are looking now at a ban on replacement fossil fuel boilers in large commercial buildings from 2024 and everything else, so small commercial and residences from 2026, which is very soon. This is 4 years away, and most of the rural communities, and I live in one myself, that are off the gas grid, most of them have no idea this is coming at them. So we really do need to get a serious educational piece out there to start preparing people for this change. So yes, answer to your question. It was a long answer to your simple question. This is about displacing carbon, and actually it's not just carbon. Carbon is the thing that's bad for the planet, but in terms of air quality, it's the NOx, the SOx, and the particulates that are damaging for human health.
Okay, so industry is going to come first then. So to the businesses that are listening to this, I would imagine what's one question that's in their mind is, well, how easy is this to adopt? What's the process like? How complicated is it?
There are several schools of thought about this sort of complexity issue. Clearly, those that don't want electrification to succeed, very keen to paint it as being very complex, very costly, very demanding, very difficult, and probably isn't going to work very well. Well, if that was true, of course, we wouldn't be selling any heat pumps at all at the moment. And last year, domestically, we did about 75 to 80,000 units. So we wouldn't have done any of those if it was true that they didn't function. Commercially, heat pumps have been in use rather more for rather longer, of course, because all your supermarket chillers, effectively all your air conditioning units in hotels, offices, those are all heat pumps. We just never referred to them as a heat pump. We call them air conditioning. Actually, in many cases, they're not even air conditioning. They are just air-to-air heat pumps. They don't actually condition the air. We condition air in places where we need to, so archives where we're storing historic materials or whatever, but most of the units that we describe as being air conditioning are actually just air-to-air heat pumps. So again, in commercial applications, we've been actually much more used to using heat pumps than we think, but we've just not called it a heat pump. So the transition, I think, for many commercial players could be more straightforward than they might imagine. Now, we can provide space heating, we can provide space cooling, we can provide potable hot water, and of course, we can do process heat. We now have heat pump technology that will relatively routinely give us 85 degrees. We've got steam generators, heat pump steam generators now, and the technology boundaries are being pushed all the time. I think some of the research in Europe and Scandinavia, they're now looking at generating 180 degrees from a heat pump. Clearly, efficiencies are nothing like as good when you're developing those sorts of temperatures. But if you're displacing direct electric heat and your efficiency is 2 to 1, your operational cost is still halved. So there are still massive advantages to be had depending on what it is you're displacing.
Okay, so from a commercial application, then you've demonstrated this is not necessarily new technology, that it's widely used and available. So I'm sorry to sound as though I'm looking for the problems, but it's important to try and set the whole stall out. So does installation take a longer period of time, and what are the sort of associated costs? Are they all broadly similar to replacing existing equipment with the new for old, and all you're trying to do is shift people to this much more efficient technology?
So in the first instance, when you're transitioning from a fossil fuel to a heat pump, clearly deployment time and cost is going to be higher. What I try and liken it to is the process that we went through when we were deploying central heating into homes for the first time, when we were retrofitting homes with central heating. Clearly, that was very disruptive, floorboards up and plaster off the walls and all sorts. Putting a heat pump in is nothing like that disruptive in most instances. But we have the point of that is that we've been here before, we've been through big transitions before. So in the first instance, migrating from a fossil fuel system to a heat pump system is likely to cost more, it will cost more money, and it will be more disruptive, and it will take a bit more time. But once you've got the system in, replacing the heat pump periodically in the same way you replace a boiler will become exactly the same. You just replace the heat pump in the same way you would replace the boiler. So there is an initial cost, and we are currently working with government to come up with new and innovative ways of dealing with that affordability issue, both for consumers and for businesses, so that we can enable people to make these decisions and make good decisions about moving away from fossil fuels. So that affordability piece is now becoming critical, because I think the technology, we have the answers from the technology perspective, and we can provide the levels of reassurance to people from a technology perspective. But it's the affordability that we've got to be able to address and make sure that there's appropriate consumer protections in order to build the confidence in the market. Because I think a lot of this is now about confidence. We've got to provide people with the confidence to make these good decisions about removing fossil fuels from their estates, whether it's from hotels or gymnasiums or churches or health centres or schools or retail outlet. We have a solution for every single application. We're doing a lot of work in agriculture, for example, huge amount of work going on in grain drying, in cold storage, food storage, potato storage, chicken sheds. I mean, you name it. We're doing a huge amount of work already, which largely goes unsung. I mean, we're very bad at getting onto social media and saying how successful things have been over here. We tend to take to social media when we've got something to complain about. But you'd be, I think, quietly amazed at how many really good parcels of work are going on. Clearly, we have failures. We're like every other industry. We do have failures, and of course, those make the headlines. But actually, if the consumer, and it doesn't matter whether we're domestic or commercial now, and I appreciate listeners today are largely on the commercial side, that doing a bit of due diligence and making sure that you get into bed with the right people who have the experience to deliver the outcomes that you need, that's the bit that consumer has to do. And at the Federation, we're very keen to help people do that. We publish advice for consumers on our website already. We label it as domestic advice, but actually the procurement advice contained is just as applicable to those in business, whether they're looking for space heating, cooling, both, and or process heat.
And we will put a link to the Federation's website with the show notes that go with this podcast.
Excellent.
So for the businesses that are listening to this then, so they would, I would imagine, traditionally have a boiler room, lots of big kit and pipes and so on. So what does the future look like in that respect?
Well, the future doesn't look that different. I mean, depending on which variant of heat pump technology they adopt, and that will be determined by, what natural assets do they have. So, for example, many breweries are sitting on rivers because they needed access to water. And so water source heat pumps, of course, become a natural first port of call in those sorts of scenarios. So depending on what assets the site already enjoys, we might look at different ways of deploying heat pump technology. So that would be the starting point. What do you need? What does the consumer need? What natural assets do you already have? And there'll be other instances where perhaps you've got a lot of roof space, in which case deploying solar PV alongside a heat pump, so you're generating electricity, which you then use in your heat pump. That is also a natural combination. So the conversations, I think, start with how do we go about finding a really good provider, and the trade bodies, ours, and there are two other trade bodies will help and guide people towards picking providers that can deliver the sort of expertise and the sort of outcomes that are required. And then it's a conversation about what are your loads, what do you need, what time of year do you need them? Can you take some flexibility? Because your listeners, I'm sure, will be aware of the concept of charging electric vehicles overnight on low cost, low carbon electricity with appropriate thermal storage. And that doesn't matter whether it's warm storage or chilled storage. We can do the same with heat pumps. We can run them overnight on low cost, low carbon electricity and deliver some fantastic flexibility value. And in fact, Ofgem have belatedly woken up to the realization that there is more flexibility value, this concept of shifting load from peak times to times of the day when electricity is more readily available and when demand's lower and when the price and the carbon factor tends to be lower. That concept of flexibility in heat actually has the potential to be rather more valuable than the flexibility available from electric vehicle charging. So there are some enormous opportunities to benefit the wider economy here. So not just for the individual businesses to take advantage of ultra low cost electricity, But that has a massive advantage for UK PLC because it means we don't have to put the extra wires in the ground. We don't have to put the extra generation capacity down. So all of those people who are worried and concerned that our network and our generation capability cannot cope with electrification, both of electric vehicles and of heat pump technology. Actually, I am quietly confident that if we take advantage of all these options around load shifting, control management, we can actually keep generation and network development running at the same pace as we are electrifying everything and avoid the sort of cataclysmic disasters that some people like to suggest are likely to happen.
So that's encouraging that we're aware the price of energy is soaring and it doesn't look as though it's going to stabilize anytime soon. So switching to this technology is efficient from a financial point of view, is I think really what you're telling me. But what about in terms of carbon saving?
Oh, well, the carbon saving potential is enormous, of course, because as we increasingly decarbonize the grid, sort of decreasingly decarbonize the grid, however you look at it, then the heat pump that we deploy this week is going to be more carbon efficient in a year's time than it was this week because the grid will have continued to decarbonize. And of course, if you're locally generating, so if you are using PV or a wind turbine or a water source technology to generate your own electricity, then you're effectively going to be zero carbon almost immediately, apart from the embedded carbon in the devices themselves. So the carbon benefit is enormous. And if you look at what's happening to the grid at the moment in SAP and RD-SAP, which are the protocols that derive your energy performance certificates for domestic and some commercial buildings, the assumed figure for the carbon intensity of the grid, the national grid, is 519 grams of CO2 per kilowatt hour. Well, that's based on the fact that we used to generate most of our electricity with coal. And that figure dates back to 2011-12. Clearly, today, the carbon factor for grid electricity is significantly lower. I think I looked at it this morning, and it was sitting at about 160. So 519 down to 160. If we've got a day when there's very little wind and the sun's not shining, clearly that figure goes back up again. But even then, we're only looking at about 300. So we've already done some savage damage because then we use the electricity very efficiently. If we get 3-to-1 out of the heat pump, if the grid's running at, say, 210 grams of CO2, that heat we derive from a heat pump operating at 3-to-1 is actually only generating carbon emissions at 70 grams of CO2 per kilowatt hour, compared to natural gas being combusted at an efficiency of 90%, sitting at around 230 or so grams of CO2. So we're already, even this year, we've still got a long way to go in decarbonising the grid. We're already savaging carbon emissions by deploying heat pump technology. So if that's the priority, and different businesses will have different priorities around ESG. Very large businesses, of course, will have carbon reporting they have carbon reporting obligations. So if carbon is the priority, then electrification absolutely is the way to go. If it's operational cost, then making use of these flexibility mechanisms start to become increasingly valuable. And we will become increasingly capable in this respect. Capability and experience will march with demand. So as businesses want to move away and want to migrate away from fossil fuels, so our industry will develop the skills and experiences. At the moment, one has to seek those out, but like every other developing technology, and we're seeing it with electric vehicles already, servicing an electric vehicle used to be a challenge. How many people can actually service electric vehicles? Well, the automotive sector is transforming that capability, and we will be doing largely the same.
Yeah. So I can hear listeners in my head, Bean, who are saying, okay, right, I'm interested. This sounds attractive. It sounds the sort of thing that I should be moving the business towards. But I did hear this guy say to me a little bit earlier on that it costs more in the first place. So let's just talk about, are there any grants available that can help businesses make this transition?
At the moment, the only grant available from government is something called the Boiler Upgrade Scheme. Rather odd name, although of course it is the bus. So get on the bus, which I think government rather likes. So the Boiler Upgrade Scheme is open to domestic consumers and commercial premises but it has a thermal limit of 45 kilowatts, which is the microgeneration certification scheme limit. So that's been adopted. So this only works for smaller businesses. The non-domestic renewable heat incentive, which was the subsidy scheme for commercial businesses, whether space heating or potable hot water or process heat, actually applied to everything, that closed to new entrants, unfortunately, a year ago, and there is no current replacement. But one of the work streams that we have going on with government at the moment is looking at this whole issue of affordability and future funding. And one of the core aspects here is making provision for those that want to transition to access the capital at an affordable rate. And that is key. We've had a recent instruction from the Chancellor to the National Infrastructure Bank to start looking at this particular aspect. And indeed, it is National Infrastructure Bank that they'll be one of the parties that we'll be working with in concert with government on this work stream on affordability, because that is now, for me, the key. You know, we understand the technologies very well. Our skills are developing very well. Clearly, we need more installers, and that we're also working on. The training schemes have improved massively over the last 2 or 3 years. But we need now to provide this affordability piece.
And of course, for businesses here in Coventry and Warwickshire, there is the Green Business Programme, and there may well be grants available that businesses can access there. Just finally, Bean, you referenced a little bit earlier on talking about the net zero legislation and the laws that are coming into place that could in fact force businesses and individuals down this path of installing heat pumps. Just go over the period of time again, just so that people understand what's on the horizon.
Sure, because I think this messaging is critical. We need, I think, the understanding of the implications for the timeframes is not yet good enough. So I'm really pleased that you want to highlight this to listeners of this podcast. So I think most people are very aware of the net zero legislation. So we've had this in place for several years now. The UK has a legal requirement to be net zero by 2050. So that's the big target. So we've got 28 years now to get there. And we've got roughly 28 million buildings to deal with. So we're looking at doing 1 million buildings a year on average. So even that is a challenge. 28 years sounds like a long way, but actually it's a challenge. In the short term, we now have government consultations on the removal of fossil fuels from off gas grid. So there's a distinction between on gas and off gas, largely driven by the fact that natural gas is a lower, it's still high carbon fuel in my terms, but it's lower carbon than oil and LPG. So the concentration is on those two, on off gas, and the two consultations in play currently, government will be reporting on those consultations sometime in the summer, are calling for a effectively ban on replacement fossil fuel boilers off the gas grid for large commercial premises, which they make a break at 1,000 square meters from 2024. Don't know whether it's the 1st of January or the 31st of December, of course. And then the equivalent for smaller commercial and all dwellings from 2026. These are only 2 and 4 years away, respectively. So if these consultations go through with the timeframes unchanged, then this is a challenge, and we need consumers to start getting their heads around these things. It doesn't mean you've got to rip your boilers out prematurely. What it means is that from those dates, whenever they come in, you will just not be able to replace your boiler. So some people might choose to replace early, so they feel they've got a boiler lifetime still left. But others, as the boilers fail progressively over the next sort of 10, 12 years, fossil fuel boilers lifetime is 10 to 12 years or thereabouts, they would have to then start transitioning. So some form of planning, some element of planning is essential. So when you're servicing your fossil fuel boilers, you just need to be aware of what the implications are. When the engineers tell you that the boiler's got another year left in it, it's time to start planning once we get those pieces of legislation in place. And then looking a bit further down the track, we have 2025, the introduction probably of the Future Home Standard. Again, this is not in legislation yet. And that will take all new build away from fossil fuels. And then ultimately, the potential to start dropping out natural gas, but that isn't projected to come till sometime well into the 30s, probably 2035, something like that. But again, that's nowhere near consultation, let alone anywhere near the legislation.
Been really great and interesting to talk to you. Thank you very much indeed. Lots of challenges ahead. Bean Beanland from the Heat Pump Federation. Now, let's have a look at a couple of case studies. So our first case study then is looking at some work that's been undertaken on behalf of Coventry Council. So Chris Dooling, who's the managing director of VWG Mechanical, he just joins us right now. Hi, Chris. Thanks for sparing the time. Just tell us a little bit about your business.
Hi, John. VWG, a mechanical services contractor, work throughout the country, undertaking all sorts of off-site and on-site mechanical services works. So primarily building services, installations within industry and schools, higher education establishments and commercial properties.
Okay, so you're working with the council to help them save carbon and do their bit. What projects are you involved in?
Yes, over the last couple of years in particular, as the funding's been put out there and made available by the government, being heavily involved in the decarbonisation strategy that is being pushed at all levels. Companies such as ourselves is primarily involved with the installation of heat pumps, for us in particular air source. So we've been working very often on a design and build basis to take a concept idea, to take that and apply it to an existing building installation that is commonly served from a natural gas heating plant. We've been looking often to fully remove the natural gas heating provision and replace it with electric driven heat pump. On some occasions, some of the schemes, the natural gas has remained in as a backup or to serve part of the building load, and we have installed heat pumps to serve just a part of the system.
Okay, so specifically, you've been working at the Central Library and at Cannon Park School. So can you tell us a little bit about the challenges that you face there?
So both quite different schemes. Start with the Central Library, so that a listed city centre building, but it's presented challenges both logistically within a city centre, but also the level of the plant room, which was on the roof level. And also we had to be mindful and very conscious of the weight and the structural loadings across our equipment that we installed. So because we were going down the air source heat pump route, we have to find space externally to site these. There was a flat roof area to the plant room, and this is where we installed a self-supported deck system, an integrated louver system, because there was many neighbouring apartments in the area, and we were able to install the said air source heat pump system to replace the natural gas boiler installed. We also applied two different types of heat pump to the system, so one at traditional operating temperature, but we also installed a higher temperature heat pump, which is fairly new to the marketplace. This is able to produce temperatures up to 70 degrees. So, that opens up many doors when it comes to being able to retrofit air source heat pump systems to old natural gas.
That will be particularly of interest, I presume, for other applications in industry, would it?
It would, because the traditional design parameters for the natural gas system of thereabouts 80 degree flow temperature. Now the heat pumps are coming to the marketplace and they're achieving close to these flow temperatures, then it opens up the doors to be able to use this technology to replace the gas boiler. And around domestic hot water application, there wasn't such a domestic hot water requirement library. Now the heat pumps can achieve temperatures in excess of 65, then it does open the door for a fully electric-driven solution.
So it sounds that the library plant room being on the roof, that presented some challenges. Was the retrofit easier at Cannon Park Primary School?
It was, in respect the works were able to be undertaken out of school time during the summer recess period, and we were able to prefabricate a lot of the pipe work and the plant room off-site. So when it came to us getting access when the school closed, we already had the majority of equipment and pipe work ready. This reduced the time on site. Again, space was all of these jobs required is because the air source heat pump needs to be located externally, then you need some external space to locate it. And the Cannon Park, we had some external space behind the plant room, so this worked well, and we were able to install new emitters throughout the school which work well with the operating temperatures of air source heat pump being operated on a lower temperature. The fan convectors that we installed give a quicker reaction time, and the install went well. It was a traditional sized junior school, age range up to 11.
These are major undertakings and pieces of work. When are you expecting the work to be complete and the benefits start to be seen by the council?
So the schemes are installed, that both are just waiting for the integration of the increased electrical infrastructure or the electrical upgrade works that is required to both. As I'm sure Coventry will sub, you have to be mindful that there's potentially, dependent on whatever the existing electrical capacity is at the site, they may require upgrading to accommodate the heat pump. So as soon as the supplies are upgraded, both systems will be tested finally, take final testing and commissioning and go live.
Excellent. That was Chris Dooling from VWG Mechanical. So let's just go to our second case study now. We're joined by Carl Grocott, who's the Managing Director at Phoenix Renewables. Now, Carl, thanks for sparing the time to come on the podcast. Just tell us a little bit about your business.
So Phoenix Renewables and Phoenix Gas Service have been trading for 25 years, more of a social housing specialist. We are gas-based initially, but we've diversified into renewables probably 10 to 15 years ago. And alongside that, we've moved into commercial offerings, electrics, tried to sort of go down the route of the whole house approach for both domestic and commercial. If it's something that needs doing, 9 times out of 10 we can either do it or we can facilitate it. And some of the changes in legislation and movements into the renewable industry that are taking place, they're a good fit to what already existing business was already doing.
What about the projects that you're involved with?
Been sort of numerous projects over the last 12 months, really. I think it's been linked to a lot of the government funding that started to be driven for the decarbonisation. We've recently carried out a couple of projects for Coventry Council. One was the Limbrick Wood Centre, and the other one was for the Mosaic Family Hub. That was an installation of 2 commercial heat pumps with an upgraded heating system on site, alongside working with other contractors, I believe, with regards to installation works.
So these are existing buildings where you're going in and fitting this new technology. What sort of challenges does that present?
Retrofitting anything to any building is a challenge in itself. It's a lot different than a new build as such. I think one of the things that we're facing at the minute is manufacturing issues. That's sort of felt across the industry, across the board, really. It's supply and demand, and then the manufacturers actually having the components to build. So a lot more time takes in preparing the projects. The lead times for delivery of the items are a little bit more stretched, but planned properly, we can still deliver the projects. We can overcome that. A big issue at this present time is skill set. It's a problem that's across the industry, and it's something that the whole industry is going to have to address over the next few years, and trying to upskill people, taking the time to try and create a new labour force for a new industry that we are trying to boost via the government's incentives, really. Other problems that we come across is DNO applications.
Just explain what that is.
Yeah, it's an application to the direct network operator for the electricity supply. We're changing the consumption on site of the electric based on the commercial electric heating instead of the gas heating. So we have to ensure that the connection that's on site is sufficient for what specifications on there. And sometimes we have to upgrade the connection, and that can take, 2 to 3 months? The issues is realistically connections to the substations. Due to the demand for some of these schemes that are out there, some of these substations need to be upgraded to be able to facilitate some of these designs, which again is causing backlogs and delays to some of these projects.
Okay, so Carl, so let's just assume that there's been some great planning, because you've told us that that's part of your expertise, and you can get all the bits and pieces and all the materials that you need. From an outcomes point of view, what's the customer going to end up with at the end of the day?
Obviously, initial driver is obviously there's a decarbonisation of buildings. So with that, there's going to be carbon savings, which can be reviewed once obviously everything's completed. And it also reduces long-term reliance on gas. It's a driver to becoming self-sufficient of some description. There should be energy savings and reduction in energy consumption based on the heat pumps have a 3-to-1 ratio over gas. And there should also be cost savings in relation to the price of electricity to gas. Again, that's hard to rubber stamp in this current marketplace, but the way in which we try and discuss with our clients is more about a saving in kilowatt consumption and not necessarily so much on price, because it's fluctuating every 3 months. It's hard to give a definitive cost saving. It's more an energy consumption saving, which then we can work back in the future.
But it sounds like there are sort of three really strong drivers for why councils and other businesses should look at adopting this technology.
Yes.
That was Carl Grocott, who's the managing director at Phoenix Renewables. So we hear and we know it's a challenge and you need to get some good advice, but help is available.
The core message here is that, yes, this is a challenge, but there are people who want to help, and we're one of them. I think that's the thing, is people reach out and ask for help, they will find it. The problems are going to come where people think they can go it alone. Getting really good advice, I think, is important, and that applies to local funding as well, of course, because, whilst we know what the national picture looks like, we are not that well equipped to discuss local funding. And in that respect, places like Coventry are probably running ahead of many, many other places. Manchester are doing pretty well. Leeds are doing pretty well. Bristol does pretty well. But I think Coventry is doing a pretty good job and a good job at getting the message across.
Don't forget, the Green Business Programme can offer up to 40% as a grant for adopting green technology. Please use the link in the description that accompanies the podcast to let us know if you're interested in accessing the programme or becoming a member of the Green Business Network. By becoming a member, this allows businesses to come together, share ideas and promote energy, resource, waste and water efficiency, as well as engage in low carbon, environmental and green sustainability initiatives. With almost 2,000 active members, the network is free to join and open to everybody. Thank you to my guests, Bean Beanland, Chris Dooling and Kyle Grocott. We hope you've enjoyed this episode. The producer of the podcast was Maria Kovlia. I'm John Bates. Thanks for listening.